So section 5 is about variation. It is our last section of module 2. So when we talk about variation, a definition would be helpful about what exactly variation is. And variation is just a relationship with regards to the change in the value of a variable when the values of the related variables change. So you're going to have multiple variables, and a variation just describes that relationship. And there are 3 types of variation we're going to be talking about: direct, inverse, and joint. I'm going to give you the definition and then the general equation that represents that type of variation. So when we start with direct variation, so when we talk about direct variation, we're talking about a relationship between 2 variables in which one is a constant multiple of the other. And the most common type of a direct variation example would probably be an example of hourly wage. So you work X hours, you earn $9 an hour. So depending on the number of hours you work, your relationship between your take-home pay and the amount of hours you work is a constant multiple of whatever that hourly wage is. So when we talk about the general equation, it's just going to be y equals kx. And k is going to represent what's called our constant of variation. So k is the constant of variation. Every type of variation is going to have this constant k that you're going to have to solve for first. Our second type of variation is an inverse variation. So inverse variation is a relationship between 2 variables in which the product is a constant. So its general equation would be xy equals k. So the 2 variables x and y, when I multiply them together, I'm going to get my constant variation k. But we're typically going to look at our variation equations as a y equals. So you're typically going to write it as y equals k over x. So we're going to represent our equation in terms of y. And k still represents that constant of variation. Our last type of variation is joint variation. So joint variation is not a relationship between 2 variables. Joint variation involves multiple variables. So a variable which is proportional to the product of 2 or more other variables. So a joint variation is going to have multiple relationships. They could both be direct relationships. The product of our two or more variables could be direct. They could both be inverse relationships. They could be a combination of direct and inverse variation. It's just a product of more than two or more variables. So the way we write its general equation is y equals kxz, where x and z are our two other variables. So every single type of variation involves our constant k and variables x and y, and in the case of joint, z. So let's go ahead and take a look at some examples of how these problems are set up and how we solve them. Let's look at our first example. So our first example says, suppose y varies directly as x and y equals 27 when x equals 6. We want to find the constant of variation. So you first want to identify the type of variation we're looking at. And it says varies directly. So I know from the table that the equation for direct variation is y equals kx. And because we want to find the constant of variation, to find k, we plug in the values of x and y that we know. So we know y is 27 when x is 6. So we're going to go ahead and plug those in. So we get 27 equals k times 6. And then to solve for k, all we have to do is divide both sides by 6. So we get k equals 27 over 6, but that is a fraction that can be simplified since 27 and 6 are both divisible by 3. So our constant variation k is going to end up being 9/2. And I would use this constant variation 9/2 if I wanted to find any other values of x or y, given I know one of them. So you have to find the constant variation before you can solve for any other values. So that's what we're going to do in our second example here. So if y varies inversely as x and y equals 21 and x equals 15, find x when y is 12. So let's first figure out what type of variation we're talking about. So it says right here we're talking about an inverse variation. So I know inverse variation is y equals k over x. And in the problem, we want to find x when y is 12. Before we can do that, we need to know what k is. And that's where this y equals 21 and x equals 15 come in. We're going to use them to find our constant of variation. So we're going to replace y with 21. So we get 21 equals k over, and then we'll replace x with 15. Now in order to solve for k, we have to get rid of that 15. So we're going to multiply both sides by 15. So we get that k equals 315. So now that I know k, I can go ahead and rewrite my inverse equation with my known value of k. So I can write it as y equals 315 over x. So now that I know k, I can go ahead and answer the second part of my problem. Find x when y is 12. So I'm going to go ahead and plug in 12 for y. So 12 equals 315 over x. And now I want to solve for x. The easiest way to probably solve for x is go ahead and write 12 as 12 over 1 and cross multiply. So we get 12x equals 315. And then we're going to divide both sides by 12. Well, when I divide 315 by 12, it is a decimal, which we want to leave it as a fraction. And we're going to write a fraction in simplest terms. Well, 315 and 12 are both divisible by 3. So when I divide them both by 3, I'm going to get 105 over 4. So x is 105 over 4. So looking at our third example, we have if y varies jointly as x and z, and y equals 12 when x equals 9 and z equals 3, find z when y equals 6 and x equals 15. So let's start with identifying our type of variation. And it is a joint variation, and it's jointly as x and z, which is just going to be a product. So we're going to have y equals kx z. And in the problem, we want to find z. Well, I can't find z until I find k. So we're going to go ahead and plug in the y equals 12, x equals 9, and z equals 3 in order to solve for k. So 12 equals k times 9 times 3. Well, I'm going to get 12 equals 9 times 3 is 27k. And then to solve for k, we're going to divide both sides by 27. So k is going to be a fraction, and anytime we have a fraction, we're going to want to simplify it. 12 and 27 are divisible by 3. So I'm going to get k is 4/9. So now I can rewrite my equation, knowing k, y equals 4/9 xz. Now I can go ahead and do the second part of my problem. I can find z when y is 6 and x is 15. So we're going to have 6 equals 4/9 times 15 times z. Well, instead of multiplying 15 by 4 and then dividing it by 9, I'm going to go ahead and simplify first. 15 and 9 are both divisible by 3. So I'm going to go ahead and divide those by 3 now. So the 9 becomes 3, the 15 becomes 5. So I'm going to get 6 equals 20/3 z. In order to solve for z, I need to get rid of my fraction 20/3. So I'm just going to multiply both sides by its reciprocal. So I'm going to multiply both sides by 3/20. And again, this is 6/1. So we're going to get z equals 6 times 3 is 18/20. And I do want to simplify 18/20. I can divide them both by 2. And we will get z is 9/10. And we're not always going to get fractions as our answer. We will get whole numbers occasionally. So don't be alarmed that all of my examples so far have involved fractions. So let's go ahead and look at our last example. So our last example says the volume of the cone varies jointly as its height h and the square of its radius r. A cone with a radius of 6 inches and a height of 10 inches has a volume of 120 pi cubic inches. Find the volume of a cone having a radius of 15 inches and a height of 7 inches. So it's got a lot of information. So let's point out the type of variation we have going on. So we have a joint variation. And instead of x, y, and z, we have volume, height, and radius. So it's going to still work the same way. So we know the volume varies jointly. So we have our constant variation k as the height h and the square of the radius. So it's going to be h and r squared. So this is my equation, v equals khr squared. So we need to find the constant of variation. So that's what this second sentence gives us. It says when we have a radius of 6 inches and a height of 10 inches, we have a volume of 120 pi. So I can go ahead and replace V with 120 pi. I can replace H with 10, and we can replace R with 6. So then we get 120 pi equals K times 10 times 36, which gives us 120 pi equals, and then 10 times 36 is 360, so we get 360K. Now to solve for K, we're going to divide both sides by 360. So we get K equals, I'm going to go ahead and simplify 120 over 360, and it's going to become 1/3. And we still have our pi, so it's going to become pi over 3. So now that we know we have our constant and variation, we can rewrite our volume formula. So we're going to get V equals pi over 3 HR squared. Now we can go ahead and solve our problem. So it says to find the volume of a cone having a radius of 15 inches and a height of 7 inches. So I can go ahead and replace H and R. So V is going to equal pi over 3 times 7 times 15 squared. So that's going to give me pi over 3 times 7, then 15 squared is 225. Now instead of multiplying 225 by 7 and then dividing it by 3, I'm going to go ahead, and I know 225 is divisible by 3, so I'm going to go ahead and do that division now. So 225 divided by 3 is going to give me 75. So we're going to have pi times 75 times 7. So I'm going to leave my final answer in terms of pi. So I get my volume is equal to, and then 75 times 7 is 525. So I get 525 pi. And because we are talking about volume and we do have units in this problem, my units are inches, I'm going to get inches cubed. So my volume is 525 pi cubic inches.